For each of the quadratic functions below, find the coordinates of the vertex, determine if the vertex is a maximum or minimum, and write the equation for the axis of symmetry. So this is given to us in standard form. We know that A is -2, B is -8, C is -3. So if we're looking for that axis of symmetry, we know that x equals -b over 2a for that equation of that line. So that's -8 over 2 times -2, and that becomes 8 over -4, which is -2. So our axis of symmetry is x equals -2. Now we'll look for our vertex. We know that our vertex falls on our axis of symmetry, so we know that x is -2. And that's coming from calculating our axis of symmetry above. Now we need to figure out the y value that corresponds with this x value for the vertex. Now they've defined y to be -2x squared minus 8x minus 3. So that means we're going to plug in -2 for x to calculate the output y. Following PEMDAS, I'm going to square first. Y equals -2 times 4 minus 8 times -2 minus 3. Now we will multiply -8 plus 16 minus 3, and now we'll add from left to right. -8 plus 16 is 8. 8 minus 3 is 5. So we know the y value for our vertex is 5. Now how to determine if it's a max or min? Remember, we connect to that a value. A is negative, so that means we have a sad parabola, which means the vertex is going to be a maximum. So A, B, and C help us to calculate all of these different parts of the quadratic function. So same idea here. Y equals x squared minus 4x plus 1. We know that A equals 1. B equals -4, C equals 1. If we want that axis of symmetry, we know x equals -b over 2a. That's going to be -4 over 2 times 1, which is 4 over 2, which is 2. So our axis of symmetry is x equals 2. Now moving over to the vertex again, we know that vertex is going to be a point, and that x value is the same x value from our axis of symmetry. Now we're trying to figure out the y value, the output, for that input x value. We know y equals 2 squared minus 4 times 2 plus 1. Squaring, we get 4 minus 4 times 2 plus 1. Multiplying, y equals 4 minus 8 plus 1. Adding and subtracting from left to right, 4 minus 8 is -4, plus 1 is -3. So our vertex is at y equals -3. So that axis of symmetry here, A is positive, which means that it's a happy parabola, which means that the vertex is going to be a minimum. So we use A, B, and C to help calculate important characteristics of our quadratic functions.